Taylor Series Part 4. In this video, I'm going to go over some extra or so bonus problems with you that involve Taylor Series. Now, in an earlier part, we saw that root 1 plus x is approximated by 1 plus 1/2 x minus 1/8 x squared plus 1/16 x cubed. So here, I would like you to write the 6th degree polynomial approximation to the square root of 1 plus x cubed about x equals 0. Now you have a choice. You can take a bunch of derivatives, like we've done on other problems, but that's going to get really messy really quickly. So let's see if we can figure out an easier way to do it. And let's write f of x equals the square root of 1 plus x. Then f of x cubed is the square root of 1 plus x cubed. So instead of taking a bunch of derivatives, what if we went to our series for root 1 plus x and then replaced every x with x cubed inside parentheses, giving us 1 plus 1/2 x cubed minus 1/8 x cubed squared plus 1/16 x cubed cubed. Simplifying, that gives us 1 plus 1/2 x cubed minus 1/8 x squared. But notice, that's what I wanted. So I didn't even need that last term. And I have the 6th degree polynomial approximation to the square root of 1 plus x cubed. Problem number 2. And I'm not putting down all the technicalities about convergence on the interval convergence. We'll talk about that in later videos. But just assume everything works out nicely so that we can answer the problem. So given this information in the table, let's write the 3rd degree polynomial approximation to f of x about x equals -1. So f of x, since an approximation, is approximately f of -1 plus f prime of -1 times x minus -1 to the first power minus f double prime over 2 factorial times x plus 1 squared plus f triple prime over 3 factorial times x plus 1 cubed, which will simplify down to 3 plus x plus 1 minus x plus 1 squared, because 2 factorial is 2, plus x plus 1 cubed, because 3 factorial is 6. And now let's use this to approximate f of -0.6, which simply means for every x, we will replace it with -0.6, which gives me 3 plus -0.6 plus 1, or 0.4, minus 0.4 squared plus 0.4 cubed. How about a different type of problem? Let's let g of x equal the series to the right. 1 minus x squared over 4 plus x cubed over 2 minus x to the 4th over 18 plus, leave some terms off, plus x to the 20th over 400 plus, etc. First question. It says g have a local maximum, a local minimum, or neither at x equals 0. Well, remember that g of x is f of, that would be g at 0 plus g prime of 0 times x minus 0 plus g double prime of 0 over 2 factorial times x minus 0 squared, and etc. Since we are missing the x term in my series, that tells me that g prime of 0 is 0. So we potentially have a local max or a local min, because we have a critical point there. I also know that the coefficient in front of the x squared term, negative 1/4, is g double prime of 0 over 2 factorial. Which means that g double prime of 0 is negative 2 factorial over 4, or negative 1/2. Which is clearly less than 0. Since the first derivative is 0 and the second derivative is negative, that implies we have a local maximum by the second derivative test. So how would I find the 20th derivative at 0? Well, pretty easily, because I know that the 20th derivative at 0 over 20 factorial equals the coefficient in front of the, or connected with the x to the 20th term, which says that the 20th derivative at 0 is 20 factorial over 400. One final problem. And I'll remind you of the Maclaurin series for cosine. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial, continuing on. And the Maclaurin series for e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial, etc. And in this question, I want us to write the third degree Maclaurin approximation, so centered at 0, to f of x equals e to the x times cosine of x. Now, again, I could take a lot of derivatives to do this one, but I would rather use stuff that I know and see if I can solve it more easily. So let's look at e to the x. E to the x is 1 plus x plus 1/2 x squared. I'll simplify some of these terms. Plus 1/6 x cubed. And I don't need any more terms because I'm doing a third degree Maclaurin, meaning I won't have any powers higher than x cubed. And then cosine of x, I can do 1 minus 1/2 x squared, and I would stop because I would not have the x to the 4th term. And then I would multiply things out. So let's distribute this 1 across the back, giving us 1 minus 1/2 x squared. Let's distribute the x across the back, giving me x minus 1/2 x cubed. Distributing the 1/2 x squared across the back, I get plus 1/2 x squared minus 1/4 x to the 4th, but I don't need that term because that's higher than the power we're looking for. Distributing the 1/6 x cubed gives me 1/6 x cubed minus something to the 5th power, so I wouldn't need that either. And then I can start putting like terms together. So I have 1 plus x. This x squared cancels with that x squared. And then I have minus 1/2 x cubed plus 1/6 x cubed. Now I need to put those two terms together. So I'll rewrite it one more time. 1 plus x. And then negative 1/2 plus 1/6 is negative 1/3 x cubed. And that's our answer.